Hello, everyone. My name is Gaurav. I head engineering here at Sharechat, and along with me, I have Kunal, who's part of the customer engineering team at Google. We are excited and delighted to be here to share how Sharechat is building India's largest content ecosystem on the Google Cloud. So, a little bit about how we will cover the presentation today. We'll talk about Sharechat and Moj, how we scale them, and what some of the core tenets and principles behind building a scalable system are, and how the Google Cloud provides the foundations of enabling that for ShareChat. A little bit about ShareChat to start with. ShareChat was established in 2015. It is a product that is a homegrown Indian social media platform. It bridges the gap between users who don't have English as their primary language and allows them to create content as well as consume content which is in line with their language as well as cultural needs. There are a number of different ways users and content creators can choose to express themselves on the platform. This includes video posts, images, status messages, microblogging, as well as audio and video chat. We have over 180 million monthly active users on the platform right now. One of our other products is Moj, which is India's number one short video app. It has a monthly base of over 160 million. We have more than 50 million content creators that create content in over 16 different languages. It has one of the biggest music libraries and also has a large number of unique camera filters and effects, allowing the creators to express themselves how they choose to and in the fashion that best expresses them. This platform also provides not just short video creation, but also live video charts as well as virtual commerce. So here's a summary of both the products in terms of the ecosystem we have. On ShareChat, we have over 180 million monthly active users, a large community of creators, more than 30 minutes of average time spent a day, and 2.5 billion shares on a monthly basis, and 75 million pieces of user-generated content per month. On the Moj side, we have over 160 million monthly active users, a strong creator community of over 50 million, more than 30 minutes, again, of average daily time spent a day, and 4.5 billion video plays per day. We have content creation of 100 million pieces of content a month. So in order to power this and scale our system out, I'm going to talk a little bit about our cloud and technology platform. So in terms of the journey first, back in 2020, we had migrated from another cloud provider over to Google, and we also launched Moj. So that was the start of our journey on Google Cloud. We had close to 60 million monthly active users, and Moj had just launched. Fast forward a year, we had 160 million monthly active users on ShareChat and 120 million monthly actives on Moj. And that has continued to grow into 2022, where we have 180 million monthly actives on ShareChat and 160 plus on Moj. Now, this kind of hyper growth requires a very strong technology platform behind the scenes. And when we've started with a certain infrastructure that has continued to grow and has served us really well. So the way ShareChat architecture has been built is it is a microservices based architecture where we have services written in Node.js as well as Golang, and we have 250 odd services and 500 plus jobs and pipelines that run to power a lot of our systems, including our machine learning platform and training that we do around it. So we are built on the Google Kubernetes engine. For our storage, we use BigTable and Spanner along with other infrastructure from Google as well that Kunal will talk about. But we have scaled massively, as you can see, from about 30,000 cores to when we started our journey to more than 250,000 cores. Along the way, we have launched new apps, we have launched new capabilities and features in the product, and we have also launched new services such as live, including audio and video, chat rooms, and virtual commerce. And all of this has been powered by the Google Cloud. And what I wanted to share here is that the architecture that we built 2 years ago has scaled really well for us without any major changes to support this journey. So, what are some of the key requirements and the fundamental tenets that have been our guiding some of our guiding principles to have supported this growth? So, one is agile performance. If you look at like our traffic on a daily basis, it continues to have ups and downs throughout the day, depending on time of day. Evening, we have higher loads. Early morning hours, load subsides and then goes up. So, and then there are any number of events that can trigger very rapid increase. So, for example, a political event or a big news event can spike up our traffic very rapidly by 50%. And there are festivals such as the Diwali, the Shera, Holi that bring massive increase and traffic to our platforms. One example is New Year's this year, where we had more than 100% increase in our traffic year on year. And so it's very critical that this kind of unpredictable load, the cloud infrastructure provides to us a way to have this agile performance. The second is, while performance is super critical and table stakes, we want to do this in a very cost efficient and thoughtful manner where we track today internally not just our total cost, but also we have metrics such as cost per active user that we drive so that we are cost efficient from a server point of view, but also we are building a strong business where the fundamentals are solid. Cloud wastage and cloud efficiency is one of the things that is pretty rampant these days in the industry. Just to quote a study by Park My Cloud, $17 billion of cloud spend will be wasted this year. And so, what we do is we take a hard look at how we are being built, how we can be very efficient in terms of the components we are using and be able to scale them up and down. The third is that we are continuing to rapidly release features and changes every day throughout the day. Our engineers are empowered to go update production as is needed, and it's very critical there that all kinds of changes, for instance, all the way from our database schema to API changes, which power our Android and iOS apps, are done in a way that they do not require downtime. Also, we want to make sure that any fundamental infrastructure level changes such as CPU patches, OS maintenance, security patches, software upgrades are all done in a way that it does not affect our application in terms of the downtime. The other key thing and requirement for us is that everything needs to auto scale. So all the way from our stateless services tier, our microservices, all the way up to our database tier, our messaging pipelines, our ETL systems, our and all the surrounding infrastructure that powers. That is something that is very critical. So having that as a key requirement is very important for us. So with that, I'll hand it over to Kunal, who will help us get more insights into some of the foundations using the Google Cloud components and how we've built that.
Thank you, Gaurav. Before we jump into Google Cloud components, let's look at how we are set up. This will help you establish how we are achieving the principles laid out earlier, meaning how we are cost agile, how we are performance agile, how we are making sure that all layers of the system auto scale, as well as how we make sure that the changes can be applied without taking any downtime. This is our architecture on Google Cloud. All of our microservices are hosted in Google Kubernetes engine. These services are exposed internally via L4 internal load balancers. Some large services are split into multiple clusters and are exposed via multiple ILB endpoints. In these cases, we use Cloud DNS to distribute the traffic to different clusters. Once to work with our external traffic coming in from apps, we use Google Cloud Load Balancer to front that traffic. We send that traffic to the Zool API gateway that allows us to dynamically route the traffic to different ILB endpoints. On stateful front, all the data is stored in Cloud Spanner and BigTable. Use cases that require consistency and secondary indexes are stored in Spanner. Everything else is stored in BigTable. We use Redis to cache data stored in Spanner, and all the events are collected and published via PubSub. These events are further consumed by the Dataflow ETL systems, where these events get transformed and written to BigQuery for further consumption. So let's start with Google Kubernetes engine, which is the most fundamental way we scale our systems. We run all our microservices inside GKE cluster. Since it is fully managed, we do not have to worry about operational aspects of running a Kubernetes cluster. Clusters can be upgraded automatically, and we have SLAs provided by the cloud on control in worker nodes and pods. We also scale our pods using multiple dimensions, such as horizontal pod autoscaler, which means how many pods are required to serve a particular traffic. Vertical pod autoscaler, which means what is the size of the pod should be to serve a particular traffic so that the utilization of memory and CPU remains the best. We also rely on node autoscaler, which dictates how many nodes are required to support the workload that we are running on top of GKE. If we talk about agility factor, we can go from a 1,000 cores cluster to a 25,000 core cluster in just 3 minutes. You only pay for the nodes that are provisioned. Now let's talk about Cloud PubSub. We use Cloud PubSub to capture and distribute all the events. We take advantage of the multi-region nature of PubSub to publish events in one region and consume these events in another region. One example of this is the jobs for the video processing, where the video gets uploaded in Mumbai region, so the event gets fired from the Mumbai region, but they are consumed by the workers in Taiwan region, where we have plenty of spot capacity available. PubSub is serverless, meaning we do not have to worry about managing nodes, and it also scales instantly. So when the unexpected traffic growth happens, most of the stress is often put on the messaging layer of the system. We are billed on the data processed by the system, so we are only paying for that exact usage. So we are not paying for any capacity that we have unnecessarily provisioned. If we look at the agility factor, we can go from hundreds of messages per second to thousands of messages per second to millions of messages per second instantly. It is built on volume of messages passing through the system. Let's talk about our databases now. Cloud Spanner is our primary database. We store critical data such as user information. Cloud Spanner is the only highly consistent database where we get additional throughput. Is as simple as just adding additional nodes. Using autoscaler, we are able to scale our database automatically. This results in efficient operations and higher utilization. If you look at the agility factor for Spanner, we are able to go from a 50 nodes cluster, which is serving around 500,000 QPS, to 100 node clusters, which is serving around 1,000,000 QPS in just a minute. And we are only paying for the nodes provisioned to serve that capacity. Let's talk about our second database, which is BigTable. BigTable is used for storing NoSQL data. We use this to store post data and also raw use this as a raw event store. We use autoscaler here as well for efficient utilization. If you look at the agility factor, going from a 50 node cluster which serves around half a million QPS to a 100 node cluster which will serve a million QPS, we are able to do this in just a minute. And cost is based on the number of nodes provisioned for that capacity. If we talk about our data analytics system, which is BigQuery, it is also a serverless solution. We are comfortably running petabytes of query on top of it without thinking about managing complex cluster. It is also self-service in nature, which means when the time comes to share the data with different teams, we do not have to create and rely on complex network configuration. There are multiple agility factors that comes to BigQuery, but the one which is a very important one is the streaming write, where we are able to write the data in BigQuery in real time and the same data becomes queryable instantly. We can go from writing 1000 rows per second to 100,000 rows per second, i.e. 10 MB per second throughput to 3 GB per second throughput instantly. And the cost is essentially based on how much data we have written. As you have seen with all the components we have used here, is auto scalable. And we wanted the same thing with our ETL pipelines as well. Dataflow allowed us to do just that. Dataflow scales up and down based on the number of elements processed in the system. On top of that, Dataflow also allows us to write jobs in Beam, which makes it very easy for us to test the jobs before running in Dataflow. With this, we come to an end of our presentation. You have seen how using the components like GKE, PubSub, Dataflow, Spanner, and BigTable allow us to be performance and cost agile, apply auto scaling at all the layers, and implement changes without taking downtime. Thank you, Gaurav, for joining me in this session. I hope you all have enjoyed it.
Thank you so much, Kunal. It was a pleasure. Thank you for having me.